So today I'm going to be going over a number of the changes that we've made recently in VC3D. We've recently had quite a large amount of development in it, and so the guides and any office hours I've done previously are pretty out of date. Going to start from the jump. I will have a document online. I'm going to update the segmentation tutorial and then the README. So by the time I post this, hopefully that'll be there, and then I'll put some timestamps and such in this video to hopefully kind of help out. I'll just start from the beginning. I would recommend using the Docker in most cases, just because the dependencies for VC3D are pretty complex, and you're likely going to have some issues building it from source. If you insist on building it from source, I would recommend basically just following the Docker file here. Just kind of adapt some of this for your own environment. This is for Ubuntu 24.04, but you can change some of these around. But this is probably your easiest place. Otherwise, you can pull from the Docker, which is always in this packages thing. This is the latest image gets built and updated every single time that we merge anything to the volume-cartographer repository. And you can just type this in to pull it. I have it built from source locally, but so I'm going to run it that way. If you want to run it though, all you've got to do is enter. Let me just show you this. And again, this will be in the README and the segmentation guide by the time I post this video. But you've just got to enter this command here, where you have to add Docker to your Xhost and then map any volumes that you might have. The biggest thing to keep in mind when using VC3D right now, and hopefully this will be changed in the near future, is that Ubuntu's default open file limit is rather low. You can check yours if you just do ulimit-sn like that. Yours will probably print out 1024 if you've never updated this. Just change it. I change it to 1,000,000 and then hit enter. And then make sure that this terminal is the one that you've ran that in, because it's only for the current terminal session. You can persist that through a number of different ways, but for now, this is the easiest way to do it. So to launch VC3D, though, you're going to want to make sure that you have your full package downloaded. VC3D operates on volume packages, so you need to have your data formatted in a way that's compatible with it. For what you need, just a basic volume package, you need to have volumes, which are in ZAR, OME ZAR format, and those volumes need to contain a meta.json, which looks like this. Just contains some information on what the shape of it is, UUID, anything else you might want to throw in here. But critically, the format ZAR, that's really the only difference between this one and a legacy volume cartographer meta.json. On top of that, you will need a config.json at the root of your volume package, which looks like this. And that is it. Actually, no, you'll need a paths folder. I don't think it makes that one, so you'll need to make a folder just called paths. All the rest of the folders that it needs, it'll create. The rest of the things that I have in here, so for volumes, I have a surface prediction ZAR, and then I have the raw volume ZAR, and I have a fiber ZAR. You don't need the fiber ZAR, but you will need, to do any of this at minimum, you'll need the surface prediction one and a raw volume one. Well, you don't even need the raw volume one, but you won't really be able to see anything. I have a couple other ones in here that I'll also make available on the public server. I won't use them for now, just to demonstrate. Well, I'll use one in a bit, but we have the structure tensor, which we computed the normals from the structure tensors for the entire scroll volume at a lower resolution. And then I also have fiber directions, which are dense fields basically made to try to enforce the losses to align with the fiber U and fiber V directions. These can be computed using some scripts in the volume-cartographer library, which they are located in just scripts, gen fiber, get fiber directions. That's for the fiber ones, and then the structure tensor is computed in Vesuvius using the structure tensor script in there, which exists under structure tensor create st. So that's how that one's created. You can also call it just using Vesuvius.compute st. A couple ways to call it. I think that's what it is. I'm almost certain. But that's how those are generated. Those will also be uploaded, so these will be available on the public server. And then finally, what you'll need is a folder called normal grids. You got to make sure that you have this named normal grids properly. If you don't call it normal grids, it won't find it. These are created by running a script which also exists in the volume package. It's just VC gen normal grids, I think. Let's find out. I just did this a little bit ago, but now I don't remember. And again, I'll put all these commands in the guide, which again will be posted before I upload this video. Let me just double check what that's called so I can show you the way the command should actually be written. Apps source VC. No space. Just like that. And the help will tell you what to call it. What that is just it takes some 2D slices of the surface predictions. It thins them or skeletonizes them and then computes some normals from them. There's more that goes into it, but that's the gist of it. You will need this one. You don't necessarily need the fiber ZARs or the fiber fields or anything, but you absolutely have to have this one. I'll also upload this because it's not like unique to just me. You'll be able to just download it. It doesn't take that long to generate them, but just keep that in mind. Okay, so that's your data for actually running anything. And that's the only difference, by the way, between this one in terms of like what you have to have for data between the updates and the previous ones is you need this normal grids. Couple other changes. First, let's open a volume package. To do that, you just open up the file open volume package and then navigate to a volume package. For this one, just pick the root of the volume package, just the folder that ends in .vol package. Hit choose. I've got some segments in this one, which I will remove, but I'm just going to go through the UI quick. When you first open it up, you'll see a few things. Obviously, all the colors are, if you have patches already generated, that's what those are. I'm going to switch to the raw volume. There are volume switchers right here. If you want to switch around there, I'm going to limit this to the current segment. When you have a lot of these, it has to run a number of computations to decide what to actually display on the slice that you're at. And if you have a ton of patches, it can make the UI a little bit slow. So you can check this box here to limit that only to the segmentation that you have selected. Just basic navigation, right-click pans any of these views, control-click moves your center of focus, or your focus point basically is what it's called. You'll notice around your focus point you have a few of these little like bars. When you open this up, actually, I just realized by default this is off. These axis aligned flags are off, and what it does is it tries to show you an orthogonal view of both axes in these ones, and then this is just your slices or your Z slices. And this works pretty well in terms of like trying to get you a good view of the side of the segment. But if you want to do it a different way, you can also just check this, use axis aligned slice planes. And if you do that, you'll see you have this. Both of these are your axes. So This one, and if you move this handle, you'll see it'll change the plane that I'm looking at. This is your XZ view, and this is your YZ view. And so these lines are the actual slicing plane that's generating this image. Sometimes I like to use the axis aligned ones more than the other ones, just because occasionally it can be kind of hard to tell exactly what you're looking at, which I don't have the same problem with this so much. So you can see like where this is lined up here, I now have a relatively clean like on-axis view of the surface where it's nice and flat here. And then in this one, I've got a nice side view of the segment. So just keeping these in mind, if you move these around, it might help. Otherwise, you can always just turn them off. Um, on top of that, there's a reset button. There's a couple other things. Here's your location of your focus point, which you can move around by just entering it in somewhere, and it'll move your focus point to whatever you entered. You can slice planes, pan through them by holding shift and using scroll wheel in here. And you'll see if I move in these planes, it'll slide mine left, right, or forward and back because I'm moving along that axis. Similarly, it'll move me down here if I go, or up there if I go in those ones. There's a couple more options you got here. VC3D supports overlays, so from the volumes that you have selected, you can select an overlay volume. You can toggle it on or off with spacebar, and you can change the opacity of that. There's a couple basic color maps in here. For most of your things, this really isn't going to make a difference because the color maps don't change really. You're using binary volumes or something like that. You can do something a little bit kind of tricky with it, where if you actually make your surface prediction your main volume and the raw volume and overlay, and then crank your opacity up to like 100, you can then actually view the raw volume using a color map. And you can also set like the threshold to like 100 or something like that, and then view it a little bit differently. This is not like super complicated or anything right now. The purpose was more just to actually display the overlays like this. That was the main concern, not so much actually applying color maps to the volume, just something you can do. But you can adjust your opacities and such with that. Actually, all of this stuff has opacities. You can modify your axis overlay opacity. You can modify your regular overlay opacity, which I would recommend. The intersection opacity is this line that shows where my segment is. If you set that to 100, it's not see-through at all. And you could set it down to like 30 or 50. I like to keep all these sort of transparent because it can become rather difficult to kind of see what's going on here when you've got a lot up. I would recommend if you're doing any segmentation to at least consider having some kind of predictions up because they can help you reason about what goes on in the surface. And again, you can turn them off and on simply with spacebar. Let's see. So I'm going to close this volume package quick, and I'm going to remove the paths, or I'm just going to rename the paths so we can just pretend as if I'm starting from nothing. Just a second. Oh, that's right. One more thing here. You can also move the rotation in these with the middle mouse button. So if you click the middle mouse button and drag it, you'll see my axis changes up there and up there. You can't rotate or tilt the z-axis or the slice planes up here. Those are that one's pinned, and you can't rotate the surface. So let's go over creating a initial segmentation. So I'm going to use the seeding functionality of VC3D. I switched to the seeding button here. I'm going to switch it to draw mode. There's a couple things you can do here, but this is just the simplest path to getting something laid down quick. I'm going to just find an easier spot in this scroll quick. So we can start with a basic one, sure, right here. Switch it to draw mode, and then just draw a little line that goes across it, and then if I hit analyze pass, it'll put one right in the middle. If you wanted to make a bunch, you could do that too. I'm just going to make one, and then hit analyze pass. Now just make sure when you run this actually, you're going to need a seed.json. This just has to contain the path to the normal grids and a path to a cache route. The cache route is generated on the fly, so you don't need to have an existing one, but you just have to provide a path to one. And then for your generations, I would set this relatively low. If you set this high, it'll create a very large one to start with. But for today, we're going to start with a smaller one. That way we can kind of monitor it as it grows. It's a little bit easier in most cases to just prevent an error from happening in the first place than it is to correct one afterwards, but it's possible. Once you've got this here, again, if you got your seed.json, you should be able to just hit run seeding. And it will take a second. You can see it's printing off right here. It prints off the command that it's running. When it's done, which should be in just a second here, it'll say completed. You can just hit reload, and you've got a segment. So this is a segment generated with grow patch. So this is a patch technically. There isn't really a big difference between a patch or a trace or anything like that. Really, they're pretty much all the same thing. They just kind of depend on some of the solvers, but the actual file backend is the same for all of them. So I've got this starting seed. It's rather small. Let's say I want to make it bigger. What I would recommend in most cases, what you do is if you don't use this view, that if you have axis aligned planes turned on, that you align them to be orthogonal to the sheet. So you want the sheet to go across it like this, at least in one of your views. Just grab whatever one's easier. This one, again, you could set like this if you were interested, but I usually try to get them like a little bit like that. But you can tilt these around to try to get a better view. That's the entire purpose of them. Like if I had this, if my plane was set normally, let's find like one that's diagonal. Neither of these is like a great view, but if I rotate this to be right orthogonal to it, I get a much better look at the side of it. And so you should use that to your advantage whenever you're trying to do this. Or again, you can also just use the other automatic one. I just like having a little bit of control over it, but that's totally up to you. So if I want to edit one, you need to go into the segmentation one. First have one selected, go into segmentation, and then enable editing. And you've got a couple ways you can manipulate the surface now. You can click to just kind of drag it around like old VC. The strength and the size of that pull is managed in this max radius and sigma. It's a Gaussian fall off around the point that you select. So it kind of softens out as it gets further away from your initial point, dependent on your radius or your sigma. So you can edit that way. That's one way to kind of manipulate the surface to be more like you wanted it. Another way is to go in the segmentation window, and you can just highlight anywhere you'll see these nodes get selected, and then hit F or G. And F and G will push or pull the segmentation along the normals. You can see if I do this, let's see, go right here. If I push this, if you see in this view, it's pushing that or pulling that, depending on what I do. And this is a really easy way to quickly kind of paint in surfaces. You can also segment just with this. You don't even need to look at the other views. When you grow it, you could use this to just kind of match your fiber directions quite easily. You know, if I say in a certain spot that I've got a fiber here and I don't have one over here, I can push or pull this along this normal and try to align the fiber that way. And then when I grow, I can just basically do that. I don't even have to actually see this because all I really care about is this. It's a slower way to do it, but especially if you're trying to like refine a segmentation, say ring detection or something isn't great in a spot and you want to make it better, it's a really easy way to get your segmentation like really, really, really tight to the surface. I'm going to show my overlays again. Now this initial one doesn't really have to be perfect. I'm just kind of showing some of the ways you can manipulate one. There's also another thing called correction points, which I'll show in just a little bit, that is based around the way that the surface will grow. So I'll explain that in just a moment. For now, let's grow one. The steps here are the number of generations that it will grow for. The details of that aren't really that important, but it's basically how long it will grow, so how much bigger it will make it. A reasonable number to set kind of is dependent on how accurate your surface predictions are at that spot or how frequently it's making mistakes. I'm just going to start with a low number right now. Let's just go with 10. To grow, you can either select your directions here. It gets the information from the quad surface. So contrast if growing along the normals gets the normal information from the yellow line or one of the intersection lines. And it gets it from actually from the quad mesh itself. So we call a method or a function of the surface class, which is what handles the quad surface itself or the base mesh, and we get the normals from that. They're not generated on the fly or anything. So it is dependent, when you push or pull along your normals, it's dependent on how the surface is curved, right? So if the surface is super curved here, like if you're looking at I don't know, like this, sure. If I push it along the normals, I'm going this way here or this way. So it's dependent on the sanity of your original mesh, but in most cases they're reasonable. You can grow patches using this in a number of directions. So you can grow in all directions at once, which will basically just make this triangle continue to expand out. You grow up, down, left, or right. This is relative to the 2D flattened surface. So up is up here, not up in Z. So it depends how this is oriented. So just keep that in mind. So let's say I want to grow in all directions. There's also keybinds. 1 is left, 2 is up, 3 is down, and 4 is to the right, and then 5 is all, or you can just do them here. It doesn't really matter. If you do the keybinds, it overrides these. So you don't have to like change this if you want to only grow left or right using the keybinds. It doesn't listen to those if you do. I'm going to use 5. I'll just grow in all directions. That starts a segmentation growth. You'll see it'll print off in here. And then when it's done, it'll update your surface here. So every time you grow, depending on if you're growing in all directions, basically you want to check, well, where I grew, did it grow in the right spot? I just kind of check all my edges because if it's a triangle and I grow it in all directions, my growth points are mostly centered around the edge. Well, they're right around the edge. So if you hit all corners of your triangle, usually you'll get a good look at it. We can grow again. And we're going to keep growing until it makes a mistake, basically, so I can show you how to fix it. Hopefully it'll make one soon. So far it's good. So I just click the corners like this, basically, and I make sure that while I'm going, that my middle is correct, so I never have to go back into the middle and look. I'll hit 5 again. I'm going to probably just increase the number of generations here. I picked a spot that was rather easy, so it might not make a mistake for a while. So if I increase the number of generations, I can increase my chances of that happening. You can see here that the surface predictions are a little bit off the surface. And the growth follows the surface predictions. So although it's near the surface, and if we do a render, we will end up capturing that surface right behind it. this is also a really nice spot for this kind of push and pull along the normals thing. If you're trying to make labels or um, you just want to have a really, really good segment in one specific spot. Maybe the ink signal in that spot is really weak or something like that. This is a really good spot where you can kind of just go back and paint that in. Scroll 5 is very, very bumpy, very wavy, and so you will have this kind of like pattern like this, where the surface predictions are straighter um, than the actual scroll itself is. So you can do that. It's also how you could grow. Again, if I wanted to keep growing this way, say I'm growing this direction, I can just basically paint my fibers in, and that's how I can do my corrections. Let's keep growing here. I'm hitting spacebar again to toggle my overlay. So I'm going to grow in all directions again. And this growth is, if you grow in all directions, it's going to grow rather fast. It starts out a little bit slow. I'm just minimizing this so I can see this area down here. When it's done, it'll also print a thing here and it'll update here, but I just like to see. So we still have not made a mistake, I don't believe. Let's see. So you see how I have really horrible views here? I can just hit reset, fix that. Now I've got a good one, at least in one plane. Um, you don't really need one in every plane. Kind of up to you how you want to do that, but I like to just make sure at least in one. I know that this is about as good as it's going to get, the way that this red is oriented. Sometimes I'll align the other one like maybe just a little bit off like that. Kind of up to you. So let's keep going. I'm just kind of following. I think I'm back. My headset died. Can we change the volume of predictions used to grow the patches on the fly? Yes. The volume that's used to grow the patches is here. So, and this is actually, that's a good call out. In a lot of areas, you might find we've got a number of models, right? And you might find in certain areas that one model is better than the other, and in certain areas, a different model is better than the other. So if you want to, so here's I've got 105 and 090. I can change this. I can look at them to see kind of like, hey, which one do I like more here? In this spot, they're pretty similar. But then all you've got to do is select the volume here. So you could use every single time you grow, every time you call grow, you could use a different one. It doesn't have to be the same one. Just double checking here. Let's grow again. And if this one doesn't make a mistake yet, I'm going to go pick a harder spot, so it will. Just watching this. Okay. You can see how as I get larger, a generation is more, right? So if I'm expanding by 25 steps, and from a small triangle, 25 makes a much smaller impact on the total surface area. But as it gets larger, it grows much faster. So you'll see how that could generate a very large patch very fast. I generated one the other day, again in a relatively easy area, and it's not something that like couldn't be done with the tracer exactly, but in this way you know for sure it's right. You could generate like a 25 centimeter one in a decent area in 5-10 minutes or so. In harder spots, it gets a little bit more difficult, but so let's do this. I'm going to create a new seed, and I'm going to pick an area that's more difficult so that it hopefully makes a mistake earlier, and I can show you how to fix them. So again, we just switch to our surface volume, switch to draw mode, hit analyze, and then I'm going to run a seed. When it grows the previous points in the mesh, that depends on what you set. So the previous points in the mesh just on growth, if you set no corrections or anything, they are the same, the previous ones. So your existing ones won't change at all. Well, they'll change a little bit because it rewinds one generation and then picks up from there. That's if you use no correction points or anything. But the surface that you pass to the growth is the one that you see here. So if I make a change, I'm going to make my intersection opacity a little bit higher here. If I change this to here, I got to enable editing. Hold on. If I move this here and then I hit generate, this is the surface that's getting passed, the one that was modified, not a different one. So every time you make a change, that is the surface that's passed. So I think, luckily for us, I believe it made a mistake already. Maybe not. Yeah, there it did. Okay. Let's fix our axes here so we get a better view. Maybe it didn't make a mistake, but let's find out. Actually, it looks like it didn't. But you can see how, like especially on this one, if I turn this in certain areas, it becomes much less or more clear what it is that I'm looking at. This one actually looks like it stayed on the right one, but it'll make a mistake soon because this is a pretty tough spot. So let's grow. I'm going to grow just in one direction, just to keep this easy. So it's easier to keep track of kind of what's going on if you grow in one direction. I'm going to grow it to the right, so I'm going to hit 4. You'll see that this flattens out because I'm now just growing in one direction. I believe it'll probably make a mistake here pretty soon. When you're only growing in one direction, you don't have to like move around as much because it'll grow over here. So if I hit 4 again, okay, there we go. Right? Yes. Okay, so we've got a sheet switch here. Great. Not big, happens only for a little bit, but it's a sheet switch nonetheless. You got a couple ways you can fix this. Either you can do this, you can snap it like this if you want to by just clicking, or you can use correction points. Correction points are kind of special points that the tracer can use to, it relaxes the mesh in that area and then it solves a local problem around those points by trying to just push the mesh towards those areas. So if you want to do correction points, you just hit T with editing enabled. It creates a new group. Click your first point, which is kind of a special point, and it needs to be on the mesh, and then the points after that are where it should have gone. So you just kind of click along here. If you don't want to grow the mesh, you just want to correct it, you can set your steps to 1. If you're doing corrections, a lot of the time it's probably better just to do the corrections without growing at the same time, although you can grow at the same time. And then if you just hit grow here, it'll run a small problem down here. Depending on how many points you have, this can take a little bit longer or less time. Usually it's reasonably fast. It's just a local problem. The reason I would recommend sometimes using the correction over the actual mesh pulling is because it makes a little bit saner of a mesh in most cases. You can see here we've also kind of gone down. I might have actually fixed a mistake that didn't exist. But let's see. Yeah, I did. Well, let's fix it up here. Or I didn't, it's right here. So let's fix this one. Again, you could also pull it like this. You don't have to do the correction points. Um, it's just sometimes when you do this, you can create little like pinches in the mesh if you just manually pull it. But it's also a valid way to grow it. Um, it's really up to you what you prefer. And again, whatever you pass, what do you have in your view is the surface that gets passed um, to the tracer. So these are corrections, I guess, in the same way that the other ones are. Sometimes they're just a little bit slower. And another way to check too, again, is if you've got a surface and you've got a fiber that you're trying to follow, you can kind of just paint it. Let's see here. So we know this is a good one. Now let's click over there and see what goes on. Okay, I see. This is a spot where the fiber comes way, way, way off the surface, so we lose it for a second. And that's a lot of the reason you see these kind of like things like that. But we pick it back up here. This is a good way to quickly check if your surface is sane and and make any kind of fixes that you might need to make. Is just kind of follow your fiber continuity along. In certain volumes, this will be easier than it is in other volumes. And also, if you have a colesis, it will become more difficult to go all the way across. I don't know if we have one here. We might. They're very hard to see in scroll 5, especially at the outside. But let's just call that good for now, other than right here. We're going to fix that too. And I'm doing this kind of in a slower way just to show how you can use these. But you can grow quite quick, so let's fix this one too. Again, I'm setting my steps to 1, and I'm just going to hit grow. And that'll fix that one. So that's how you can grow one. You can keep doing that over and over again, correcting where you're going with correction points, and then after you've got your surface good, you can just grow it again. I just set it to 5, for example. Hit grow. It'll grow out to the right again, and you can just keep doing that over and over again, really for as long as you want. You can see it's sticking pretty well. You don't need to see, you don't even need to have your surface predictions up for this to work. As long as they're selected here, you can grow this completely in just the regular volume view, which can be helpful. Again, I would recommend probably having some kind of surface prediction up just because I think it helps to reason about where you are, but it does make mistakes sometimes. So like here, it's made a mistake by placing another one back here. There's not 2 sheets right there, and you'll run into that occasionally. So they're not in really tough spots like this where we're very, very compacted. They're not always perfect, but I think that they can help you reason about where you are in the surface, or what's happening. So I recommend using them. And after all, the loss uses it, so if you're not looking at them, you're probably going to be confused occasionally why it's going certain directions, and that's how you know. We've got a sheet switch there, so why don't we just fix that too? So we're not switched up here, but then down here we are. Again, we just hit T, click. This is a pretty large correction, So we'll see if that works. I think it will. Sometimes the larger they go, the weirder they get. But typically they work pretty well. This one will take a little bit longer because, again, it's got to solve a larger problem. If you keep these small, they usually work pretty well. What else is there in the UI? Let's see if I can figure anything else. Right, yeah. Another thing that you can do in the GUI, I'm going to have to wait for this to finish, is erasing mistakes. A lot of the time what happens when you create a trace, if you've made a mistake, what happens is that mistake kind of propagates. And a lot of the time, especially if you've got a large correction, it can be easier. So I fixed that correction up here now, but down here it's not right. And so a lot of the times it can be easier to just erase this part. And you can do that if you're in segment editing by holding shift. It'll draw these little lines. I'm going to just try to get everything here. And then that's a path that will get erased. So if I hit E, it will just erase that whole chunk. And a lot of times, if you've corrected a mistake back here, that error probably won't propagate, and so it can sometimes be easier just to completely erase that section before you apply any edits. Not always the case, but can be good practice. So you can see it didn't grow anything. I hit 4, and it didn't grow anything because I had my steps to 1. So I'm going to set it to 4 or 10 now, and then hit 4 again, and it'll just grow back into that area. And we'll see if that makes that same mistake again. Down here, it's gone a little awry. Let's see if we can fix that. And I think it'll pull in as this mesh gets set a little bit better. Might have missed a point when I did the erasing, so I'm going to probably have to do a little bit of fixing with the eraser, but let's just correct that here. Oh, right. I forgot that. I also have, if you do if you move a mesh like this, if you hit Control Z, it'll move it back. It does that for the last 5 changes, so that's also an option. So let's just see what goes on here. This corner part is like connected a little bit strange, and I think that's because when I did the masking, sometimes when you do the erasing, if you do it right on the edge, you can run into some problems, and I think that's what's happened here. So I'm going to just grow it to the right again and see if I can get that to connect better. I need to fix the way the eraser handles the edge, which is marked with a sentinel value of -1, and if you draw there, it you can run into some problems. Let me fix the point there. There we go. So I'm using kind of a combination of clicking and point correction here. Up to you how you want to do it, really. Let's keep growing out. what I'm going to try to do is actually fix this once I get a little bit past it, which will probably be easier. But what's happening is I've got my mesh doing a stupid turn right there. Let's see if I'm able to erase that spot. Yep, there's that -1 value. So this spot might be, oh, there we go. All right, now I'm getting it to partially grow back in. Cool. Again, we'll just fix this minor one. I got to do a weird amount of touch up here because of that issue with the eraser. Perfect. We'll do one more. And you can do, by the way, more than one correction point at a time. You don't need to do only one. Each one is a separate group. And so you can do multiple groups to fix multiple things. The only thing that I would suggest is for any one of them, don't put a bunch right next to each other. Like if you try to do two corrections, one here and like one right here, it might struggle with that. So I wouldn't recommend doing that. But if they're a little bit apart, you'll be fine. All right, so we fixed up here now. We're doing okay up here. What I'm going to do is just kind of pull this a little bit to get that there. Try to get that fiber a little bit better. I'm going to grow this for just a bit longer, and then I'm going to show how you can do this with traces as well. Again, I'm trying to grow. I need to fix, I'll fix this before I upload this video, but what's happening down here is I didn't erase all of the points that I wanted to correct. And so I ended up with this situation where now I have a point back here that isn't actually showing up here. You can't see it, but it exists, and it's trying to fit to that point, which it can't for obvious reasons. So I'll fix that before I upload this. And then we'll just do a little bit of growth to the left. Why not? We're good with that. Let's just go one, grow out to the left again. And again, it's just the same thing where you're just going on your edge, seeing if your growth has made a mistake, which it has here as I went down. So I can correct that. And this actually might be a spot that I had done before. What I would recommend in most instances is to try to grow a thin band to start with, either up or either vertically or horizontally, and get yourself like a nice column or whatever row that you know is correct. And once you have that, then it should be much easier going forward. I did not do that here, and so actually the surface prediction has thrown me off because I did not have a sheet switch, and I thought I did. But you can see it pretty clearly in your surface predictions. And you can run a correction over the same spot as many times as you want. Doesn't really make a difference. Each time is a brand new surface. It's not like it doesn't consider the old points. There we go. So I fixed my mistake. We're back. Kind of adjust these a little bit. For now, we're going to move onto a thing. But you can see how you can grow it out even in a relatively difficult area, and you can adjust the quality of your surface with these brushes. Yeah, we did have a Khaleesi's there. Sweet. So let's do a trace. I have a trace in here already. If you didn't, you would right-click one of your, if you had your paths full with with patches to start with, you would just right-click one. You could hit Run Trace. Let's assume you did that already. I've got one here. I ran it for, I don't know, 30 seconds or so. Grew this one out. But actually, let's grab this one because it has holes in it. So this is like a typical output of the tracer. You get spots with a bunch of holes, and previously there was really no way to infill them. If you want to with one that you have, now just keep in mind you can't do this with an existing trace that like we generated before. You'll have to have a new one because it saves a file called generations.tiff that the previous tracing method did not save. So let's say we have a hole here. Let's pick this one. We know everything on this side, and this side is good because we've got good fiber continuity. It's just a hole. We can press T once we have editing enabled and just draw a little circle around it. We can set our surface growth steps to whatever we want. Let's just set it low because really all we want it to do right now is fill that small hole in. And then if I hit 5, you'll see it'll solve this problem. When you run on a larger mesh, it does take a little bit longer, but it's a local solve, so it isn't really terrible. What this does when you fill these points in on the mesh like this is it solves a problem of trying to map the normals in that region around there to map the normals at the point that they're currently at where your correction points are. And so it sort of like interpolates the normals along that in a way. You don't actually even need to do this to infill. You'll see these other ones probably will get infilled a little bit as well. But it's just a way to specify at least in one spot what you'd like. So you can see that's infilled, and in fact most of my holes are infilled because 5 generations is pretty small. You can keep going along like that. You can see why we have this here, why we have a hole here, is because there's a sheet switch here. So on an existing one, we can do a couple things. We can pull that up manually. Actually, I don't know that there was a sheet switch there. No, the mesh just did a weird kind of little thing there. So let's just do this again. Yeah, because it's right here. Let's see. I don't think there is a sheet switch there. I think that mesh just warped there. Okay. Well, let's see how this goes. I'm going to set this down a little bit and hit grow. We'll see how this fixes. Okay. A little funky. Oh, it's because there's still a hole there. Let's hit grow again. So I wonder, this will be an interesting spot. So this is an example of like where this can get a little bit crazy. Your mesh can get a little bit weird when it fills holes in, but let's see what happens if we just erase that. I'm kind of curious if that will infill better now. let's see. Got a little bit of issues with my masking brush apparently, so I'll have to fix those, but I will. I'm going to grow that back in now and see if that loop goes away, or if it might, what I'm thinking might be happening. Maybe not. I was thinking maybe it was stuck on this one that didn't erase properly, but it might not be actually. That might have worked, even if it looked, even if it didn't look great. I'm just growing again. I'm going to set this to 5 here, and just see. I want to see if it fills that in properly. I think it will. Okay, so it's growing it in. I'm going to just go out here for a second, only because as I do hit grow, it is growing. I'm growing it in all directions right now, so it is growing over here as well. So I'm just going to make sure that it hasn't gone off anywhere over here yet. And again, here's where the surface predictions likely lie a little bit behind the surface. So another easy spot to just kind of hit your brush quick and paint that in. That's how you can go ahead and edit these ones. You can also do, yeah, this one's gone. So we've got a very sharp curve here, like that. When that happens, sometimes your surface predictions go off a little bit, but they're probably fine here. It's just our snapping had gone over here, so we can fix that too. Again, even on a normal mesh. This one I'm going to set my generations to 1 and just hit grow. This is a very sharp curve, and in these areas sometimes patches will have a tough time following the curvature exactly. Let's see, am I back? Yep. So sometimes the patches will have a tough time following the surface exactly. In that case, the snap did work quite well. So I just placed my correction point and then put it where it went, and then where I wanted it to go, and it fixed. That's the gist of editing surfaces. So again, if you set your growth to 1, you won't grow out at all because it actually rewinds 1. If you want to correct surfaces, you hit T. When you're in editing mode, you place a point where it did go and where you want it to go, or you edit with just the clicking like this. And again, all your parameters are from here. So if you wanted to increase, say, how much it pushes or pulls at once, you could modify your push-pull step, your radius, and your sigma. And you could edit, really fast. If you make your radius really big, it affects a very large area. I'd have to make it quite big. Let's see what happens if I go to like 50. You can see over here it's pulling a reasonably large area of the mesh at once. Let's see what happens if I crank my sigma way up. Yeah, there we go. So you can affect a lot more of the mesh at once if you crank your sigma up and your radius up. I wonder, I've never really tried to go very high in this. I'm kind of curious. Yeah, you can affect a ton of the mesh at once this way. So again, this is another really simple way to quickly make edits. I mean, it's going to be kind of hard, but if you've got like, if you do a super big brush, it might be a little bit difficult to modify, but it's pretty responsive. Actually, it's not bad. So maybe that's an easier way to do it, even is with a higher sigma than I thought was reasonable to start with, because this is actually pretty quick. If I'm just pulling this slightly along. So something to keep in mind, I guess. Yeah, play with the parameters. I haven't tested these out a ton. Yeah, this is really fast. I haven't tested these out a ton, so you might find that different parameters than I have set as default are better for you than um, what the current defaults are. Yeah, wow. I should have played with this more. It's much better now. But yeah, feel free to play with it. Let me know if you run into any bugs or anything. I'll have the guide up hopefully here pretty soon. I'm planning on today, but it'll definitely be before I upload this video, and that's just going to live at the segmentation, the current segmentation guide, which is just scrollprize.org/segmentation. This will be updated, and then also if you go to the Villa repository, the volume-cartographer repo within there, the README here will also be updated. It won't be as in depth as the guide is, but it'll have some stuff. And then if you've got any curiosities about how any of this works, there's some information in the docs there. Some of them are a little bit out of date, but they're not crazy out of date. They're just a little bit out of date, as in I changed a couple things around since I initially wrote them like 3 days ago. But for the most part, they're accurate. Let's see. Do I have anything else I wanted to talk about? Oh yeah, one last thing. There are parameters that get passed to the tracer that you might not have an option for here. These you can enter here, and it'll enter it as a custom JSON object. Oh, also one more thing. If you want to add your like fiber fields, structure tensors, anything like that, to add as additional options for the solver, you just have to copy the folder here. So I'm going to select the structure tensor normal. I'll put it here. I'll select normal. This one is a scale level of 3, so I'll set that to 3, and I'm going to set my weight to something low. The structure tensor is just derived from the actual surface, so I don't like using a super high one here because it can get a little bit crazy. It's derived from the raw volume. So I set that weight rather low typically, but it will try to use that to influence the growth more or less. So I'll grow. Now that I've added that, I'll just grow up quick and make sure that that's working still properly because I changed that tiny little bit. I think we grew. Let me see here. Oh, I've got it set to 1. Now it's going. All right, yeah, so that's working. So that's another thing you can do if you've got these fiber fields or the structure tensor normal fields, any kind of direction fields, you can load them up like that. If you wanted to do the fiber directions, they're stored under horizontal and vertical, and to find the scale of one, just click in it, and then whatever this number is your scale. You can update these two, by the way, if you just change this to horizontal or normal. If you entered it wrong the first time, it'll update it there. I think that's about it, though. If you got any other questions or anything, feel free to reach out. Take it easy.